Wagwan everybody, it's your boy Mr. H. Today we'll be doing some projectile motions. So we have a question which says a ball is thrown at 20 meters per second at an angle of 30 degrees from the ground. Ignoring air resistance and friction, and would find the time of travel, total distance traveled, maximum height, and the velocity at t is equal to 1.5 seconds. So I'm just going to draw a quick free body diagram for this. That's the y-axis. This is the ground, and then the ball is thrown right here at an angle of 30 degrees at 20 meters per second. Okay, this is the ground or the x-axis, and this is the vertical or the y-axis. So I'm just going to draw a dotted line here, which denotes the y-axis here. And now we're just going to quickly find out what the Vx and the Vy is. So we're going to resolve this into its horizontal and vertical components. So I can say that because this is a right angle triangle right here, the opposite is y, the adjacent is x, and the hypotenuse is 20. So we can say that and using SOHCAHTOA, so we know that sine is going to be the opposite over the hypotenuse. So I can say that sine of angle 30 is going to be equal to Vy over 20. Rearranging for Vy, this becomes 20 times sine of 30. Doing the same thing for the x-axis, it's going to be cosine this time because it's the adjacent angle. So I'm just going to quickly, so it's going to be cos 30 is going to be equal to Vx over 20, and therefore Vx is going to be 20 times cos of 30. I'm just going to quickly solve this. So Vy is sine of 30 is a half, so that's 10 meters per second. And then 20 times cos of 30 is going to be 17.32 meters per second. Okay, so that's just, so in the beginning of any projectile motions, that's what I like to do. I like to resolve the force in the x and y, try to find out as much information as I can. So for part A asks us find the total time of travel. Now what I like to do is when I try to find the total time of travel is use the vertical component. So in any projectile motion, we know that the velocity in the x direction always remains constant. Okay? It never changes. The velocity in the y direction, however, does change. So here it is slowly increasing, and at this point, my velocity in the vertical direction is going to be equal to 0. Okay? That's one key thing that we have to know, because at the peak of any projectile motion, my velocity in the y direction is 0. So to find the time traveled, we have our Vy. So if I were to draw the projectile motion again, if I split this in half, this is going to be 1/2, and this is going to be the other half of my time. So this I can say is t half, and this is also t half. So if I use my velocity in the y direction initially, which is going to be 10 meters per second, and my velocity of the y in the finally is going to be 0 meters per second, which is at its peak. Okay, so I have my initial, I have my final. I know the component of acceleration of gravity is 9.8 meters per second square. Now using the equations of motion, I'm going to be using v is equal to u plus at to solve for this, and just quickly rearranging, it's going to be 10 divided by 9.8 is going to be equal to time, and then time, or the half of the time, and then t half in this case is going to be 1.02 seconds. Therefore, my total time is just going to be 1.02 times 2, which is going to be 2.04 seconds. All right, now let's do part B, find the total distance traveled. So to find the total distance traveled, let me just erase all this. Okay, to find the total distance traveled, what we're going to do here is that we just have to find the distance. We have the total time. Total time was given to us, which we found in part A was 2.04 seconds. We know the velocity in the x direction is 17.32 meters per second. So I can just simply do S is equal to VT and 2.04 times 17.32. This will give us 35.33 meters. That's going to be the distance in the horizontal direction. Now, let's do the next part, find the maximum height. To find the maximum height, all we have to do is we know that we found out that the maximum height happens at the peak. And at the peak, we know my velocity in the y direction was 0, and we know that t was equal to 1.02, which we had found earlier. So I can say that I have my time, I have my v initial, I have my v final. So I can use the equation S is equal to u plus v over 2 into t, and the other, this is the third equation of motion, and then I can find the maximum height. So the maximum height, I'm just going to quickly do this. This will become 10 plus 0 divided by 2 times 1.02. This is going to be 5.1 meters in the vertical direction. Okay, perfect. Now, the last part, which some students do find tricky, is going to be finding it at a specific moment in time, or finding the velocity at a specific moment in time. So we want to find velocity at t is equal to 1.5 seconds. Now, so to do this, once again, we're going to apply the same principles we know before. We know that Vx is going to be the same, which is going to be 17.32 meters per second. We don't know what the Vy is going to be, so to find the velocity in the vertical direction, I can use the equation V is equal to u minus at, and in this case, it's just going to be my velocity in the y direction at 1.5 seconds is going to be 10 minus, and this is going to be 9.8 times 1.5, which is equal to 10 minus 14.7, and it's going to be negative 4.7. So now what this negative sign denotes is that the ball is in the downward direction, or it's going downwards, because we denoted that going up in this case, in the initial case, was positive, so therefore going in the opposite direction, velocity is negative, so therefore we're going downwards. So I have my Vx and Vy. So if I were to draw out a parabola, let's say this is at 1.5 seconds. So my Vx is 17.32, my Vy is 4.7 or negative 4.7. Now, does this, if I were to move this dotted line on this side, same thing, does this make a right angle triangle? All right, this is also 4.7. This is my angle. So therefore, I can find the hypotenuse by using Pythagoras theorem, and I can find the angle of depression over here. So to use Pythagoras theorem to find the speed, let's do a squared plus b squared is equal to c squared. So it'll be 17.32 squared plus 4.7 squared is equal to c squared. I'm just going to quickly solve this. This will be 0.32 square plus 4.7 square, and then so my velocity at oops 1.5 seconds is going to be 17.94 meters per second, and the angle is just, this is just, remember, this is the opposite and this is my adjacent, so my angle of depression would be tan of my angle theta is going to be equal to 4.7 divided by 17.32. Therefore, theta is equal to tan inverse of 4.7 divided by 17.32. And all of this just becomes 4.7 divided by 17.32. This becomes an angle of 15.2 degrees, just rounding to one decimal place. All right, I hope you guys understood. If you guys have any questions, please leave it in the comments and I'll get back to you as soon as I can. Thank you. Take care. Peace.